So, the fifth type of reaction is a nucleophilic substitution reaction. The example is a alkyl halides undergo this reaction. Alkyl halides undergo this reaction. Or you can say that which compounds undergo nucleophilic substitution as a characteristic means you can say alkyl halides. Or alkyl halides undergo what type of characteristic reaction? Main first characteristic reaction is nucleophilic substitution. However, elimination also is the second characteristic reaction for the alkyl halides. So, the basic skeleton reaction may be shown in RX or a methyl chloride with a specific example when treated with the potassium hydroxide or sodium hydroxide, that is water dissolved solution. So, aqueous solution of the KOH if it is added, the OH minus is replacing the Cl minus and you are getting a methanol. So, in this reaction the Cl minus outgoing and the K forms into a KCl. This is the byproduct. So, what exactly happening is OH minus nucleophile is coming into the compound and replacing the Cl minus. So, it is basically a substitution, but incoming group is happens to be a nucleophile, therefore, I am calling as a nucleophilic substitution. Will the reaction takes place reversely, that is, for example, if the methanol is taken and treated with the KCl dissolved in the water, will you get the product means the reaction will not take place. Why is the Cl minus is nucleophile is not nucleophile? Why it is not able to replace means there should be some the proper replacement. What do you mean by this proper replacement means the OH happens to be a stronger nucleophile than the Cl minus. How can you justify or try to understand why it is stronger? The Cl minus you may call it, the OH minus you may call it as a stronger base or a stronger nucleophile. Many a time the base is nothing but the nucleophile. Base means like for example, if H plus reacts with OH minus, this I call acid, Lewis acid, and the other one is Lewis base. So, define the base means the one which gives a pair of electrons and makes a coordinate covalent bond is called a base now. So, this OH minus is donating a pair of electrons and making a coordinate covalent bond is called a base. So, the OH minus is a base. Now, here also OH minus is donating a pair of electrons and making a bond formation, but replacing the old one. There is a old one group, there is no group here. Here there is a group that is replaced. So, a substitution when you are doing with the base, I call this OH as a nucleophile. There is a small difference, and many times stronger bases happens to be stronger nucleophiles, weaker bases happens to be weaker nucleophiles, except in one few cases like iodine and in some cases, but stronger the nucleophile, stronger will be the base. So, you can take it grant the OH is a stronger. How can you justify it means where from this OH minus is formed? From water. So, water is the conjugate acid for this the OH minus. So, conjugate acid of the OH minus is water. If the conjugate acid is weak, it is a weak one, so it is a strong one. That is the theory shows a strong conjugate acid, weak the conjugate acid, its anion will be the strong. If the HCl is a strong acid, it is HCl, it is a strong acid. So, its a strong acid will generate a Cl minus, which is a weak enough. It is a weak base or weak nucleophile. So, whenever the strong acid is there, it generates a nucleophile or a base, it will be a weak. Whenever weak acid, so OH minus is a base which is formed or generated from a weak acid called water. So, therefore, we can consider the OH is a strong one, whereas Cl minus is a weak base. So, it is understood that stronger the base, replacement of weaker will become easy. Vice versa is not possible. Here what we are trying to do is we are replacing the stronger one with the weaker. That is why the reaction is not taking place, right. So, here how best the reaction takes place here and what exactly the mechanism that is the classification of nucleophilic substitution reaction. Further into based on the kinetic approach, the nucleophilic substitution reaction can be classified into nucleophilic substitution with bimolecular, nucleophilic substitution into unimolecular, based on the how many the reactive species are involved in the rate determining step. Based on that, we have a classification that nucleophilic substitution bimolecular and unimolecular, that reactions we will take later. So let us take first SN2 reaction, that is nucleophilic substitution with a bimolecular. You can read other way, bimolecular nucleophilic substitution, or literally substitution nucleophilic with a bimolecular concept. What is this bimolecular? That means two molecules are there in the reaction, or two molecules produced in the reaction. What exactly the meaning means? Let us see the one simple molecule and see the reaction mechanism. A methyl chloride, if you take, treat this reaction with the potassium hydroxide dissolved in the water, aqueous solution, aqueous dissolved KOH you take. Then this the OH minus is able to attack the ethyl chloride with methyl chloride, and then finally what you are getting is methanol is coming. Methanol is coming. Now this reaction happens to be the OH minus replacing, it's a nucleophilic substitution, right? But the OH minus mechanism, if you see, the OH minus and this bond is also polarized as a delta minus and a delta minus. So the minus if want to reach this delta plus, if it comes either from the closer side of the Cl, from the up or down, this from the closer side, because it is also electronegative, there is a repulsion, therefore from the side very much closer to the Cl minus, it is opposed. Therefore what OH will do is, OH will try to attack from the back side. OH will try to attack from the back side. Then slowly it is reaching this delta positive. The Cl will have a delta minus, this will have a delta positive, and there you can find that as the OH is coming closer and closer, and this actually it seems like this hydrogen is on the way, but actually these hydrogens are like this, there is nothing is there between these three hydrogens. So therefore the OH can exactly from the back side of this Cl, this is called rear attacking, rear side or rear attacking. Exactly from the back side of the Cl, these hydrogens are all the three sides, three are there, gap is there, therefore OH minus can reach slowly and then can make a bond formation. When once the bond is formed, the product will not be like this. If the OH is coming from the back, therefore the product will be like this. Though we have written as it is with a simple mechanism, but internally if you want to read, the OH makes a bond from the back side. What about the hydrogens? Hydrogens will go from that side, this side to that side, right? So in order to make the angle 109 degrees and the so 109, 109, everywhere wherever you measure it will be same angle. So therefore the hydrogens from this side to they fall the other side. But before reaction the hydrogens are this side, left side. After the reaction hydrogens are that side. What about during the reaction? Means you can propose a method where the hydrogens in the center, maybe at one time the hydrogens are not this side nor that side. At that time the OH is slowly making the bond formation and the Cl bond is slowly breaking the bond formation. It is not totally detached, nor this is totally attached. Both are, this is going to break the bond, slowly it is breaking, slowly it is making bond. This may be the one of the intermediate situation, but it is not intermediate reaction because step 1 is not completed. As I said, we accepted the step 1 completed means intermediate. Step 1 is not completed, and slowly it is making the bond. So, therefore, we cannot say it is intermediate species. It is passing through a stage where this stage I call it as a transition state. It is called a transition state, in which the hydrogens are not that side and this side, slowly they are in one plane, and with reference to this plane the Cl will be that side, OH will be this side, and as the OH makes bond formation, that is becomes strong and strong, the Cl will be totally removed and it will be nowhere in the picture, that will be replaced out. So, the OH is coming and the Cl is going out. So, therefore, net reaction, it is a substitution reaction passing through, called a transition state. However, how many steps are involved? This is all in one step only. So, number of steps, how many steps are involved means only one step, and this is all in one step only. Slowly the OH is coming and at the same time the Cl is going out. So, therefore, there is no more steps are involved, or the number of steps can be said as a 1, or no steps involved. Stepwise mechanism is not involved. Steps are not there here. In the previous case, steps are involved. After step 1, intermediate is formed. Here the one step itself slowly attacking, slowly going. So, therefore, stepwise mechanism is not there. You can also say this is all in one step only, therefore, 1 is there, you can recognize it, but it is passing through the transition state. If the compound is small one, there is no much discussion about this reaction, but if the compound is a bigger compound, not in exactly the bigger compound, but if the compound has got one hydrogen, right, one deuterium is there, the other one is methyl group is there, then we have a compound like this, right. Now, in this case, the carbon will become a chiral carbon. So, that means optical activity will be there, except that it has got a plus 35 degrees rotation, that is, it is a dextro compound. The carbon is now chiral carbon. So, this chiral carbon has a creating the optical rotation to the compound. So, value also randomly, I just said it is a plus 35, it is a dextro compound. Now, under this condition, if OH minus attacks, what happens, you see? It is coming from this side, right? So, back side to the Cl. So, slowly it is coming. So, all the groups from this side to that side. So, the final product, I am not concerned with the transition state, but the final compound, what happens here? The OH will be from this side, all the groups will be that side now. And this particular compound looks like a enantiomer of that one, but it is not enantiomer. Why it is not enantiomer? Because here Cl is there, here the 3 groups are same, but the fourth group is not identical. So, this if I say this is compound A, this is compound B. A and B looks like enantiomers, but not enantiomer, because functional group is different. So, but the symmetry of the B is mirror image of this one. So, definitely the optical activity of this compound will become minus value, because plus compound undergone a inversion in the configuration. All the groups from this side shifted to that side, therefore, this is called a inversion. A scientist called Walden identified this inversion as a Walden inversion. The molecule undergone inversion. That is why it is verified the optical activity has also undergone a totally upside down. So, the positive value has become minus. But what will be the minus? If it is exactly mirror image, it will be minus 35, but this is an alcohol. So, therefore, you can have a, let us say 56 or some value randomly, again I fixed some value, but one thing is sure, if you take dextro, it will become levo. If I take levo, it will become dextro, right. Value you cannot say, because it is alkyl halide, that is an alcohol, but A and B has a relationship or something very closer to the mirror image relationship is there, but not totally mirror images, because the functional groups are different. Their enantiomeric relationship is there, but not totally enantiomers. They look like enantiomers. That is why positive compound has become a negative. This type of passing through that in the transition state leads to give this inversion, and this is called Walden inversion. whenever this inversion is there, molecules undergo the plus value will become minus, minus value will become plus. So, when this happens means if it is a small compound like methyl chloride, you do not have any this implications, but if the compound has a other than all the 4 groups are different, and you cannot take big groups also. If big groups are there, then again you have a problem of steric hindrance and the mechanism turns into SN1 type of mechanism. It should be smaller groups only, but all the 4 should be different. Then this type of the application of this Walden inversion and the optical activity totally inverted compound is formed, that is the -56. So, let us take the SN1 type of the mechanism. This is called a substitution nucleophilic unimolecular, or you can say unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution. What exactly, after seeing this, I will say what exactly that unimolecular and bimolecular, where coming this comparatively you can see. Let us see the first mechanism of SN1 and then compare both, and why you are calling the bimolecular and unimolecular. Let us see. A compound like a carbon with having the some groups, not the hydrogens, some groups will be there, minimum methyl groups, all methyls containing type of the compound if I take. Then the same argument that a potassium hydroxide dissolved in the water, that is aqueous solution and heated. So, as I said, the OH minus will try to come from the front side, because there is a delta plus is there, delta minus is there, and the chlorine delta plus is there. Therefore, OH minus want to attack the front side. That is not possible, because Cl is also negative, this is also. So, front side attack not possible. In the previous case, the OH tried back from the rear side attack was possible. Now, the rear side attack is also not possible, because of a problem called all these alkyl groups are not hydrogens now. They are little bigger groups like methyl groups minimum. If you take the area which is already filled by this blocking these groups. So, therefore, the backside attack or the rear side attack is not taking place. This problem is described as a steric hindrance. Steric hindrance means a problem created by the 3-dimensionally. This we are going to see in detail later, but the steric hindrance means whenever the reaction or the attacking is not taking place just because of the not availability of the space is termed as this specifically technically steric hind. Due to the steric problem, it is not attacking in the backside. So, without attacking, how the Cl will go? So, generally the reaction will not takes place, that is what we think, but many times the SN1 reactions are more favorable than the more fastly taking place than this. That means here the front attacking, back attacking is not taking place, no doubt, but still we have some other mechanism which is helping for this reaction. What is that? We have to take it. Originally Cl minus will have a outgoing property, because electronegativity difference is there, the bond liable to undergo outgoing or the leaving property. And now here they are not hydrogens, these are all alkyl groups, will have a plus inductive effect. So, therefore, the Cl minus will have a more outgoing property when compared with the methyl chloride. This Cl outgoing property will be more, because all these alkyl groups are donating, it is called plus inductive effect, plus I effect. There are 3 plus I effects are there. So, therefore, the Cl will have a better outgoing property. That is why when the OH is not there also, a part of the alkyl chloride undergoes a removal of Cl minus. This is called minus of Cl minus. Okay. So, minus, if the Cl minus goes out, what happens? Carbon will become a positive charge. So, and this carbon cation will have a symmetry called a trigonal planar symmetry, having a sp2 hybridization. So, 3 sides, 3 alkyl groups with a plane type of structure is formed. Once the Cl goes out, the tetrahedral carbon will become a trigonal planar. Okay. This formation has some favorable factors. The first favorable factor is whenever the 4 groups are there, the sterically the groups are all the clumsy, that is closely the staying one by the side of the other one, isn't it? There is some internal the clash is there because of the non availability of the place. When one group goes, the 3 groups will have a immediate relaxation. So the gap between the 2 alkyls previously 109 degrees, it has become 120. That means there is some relaxation, that is steric hindrance is relieved. So this point first of all makes the Cl2 go out in fact. So or by Cl, if Cl goes out, that the system will get stabilized because of the steric hindrance is relieved. This is the first point. The another, that is steric hindrance relieved, first point. Second one is the alkyl groups so formed will donate a plus I effect, that is electron density, through the bond and stabilizes the carbocation. This is the 3 degree carbocation. 3 degree carbocation will have a stabilization through what means either the plus I effect or the hydrogens which are there on the alpha carbon will have a plus hyperconjugation, sometimes even a plus mesomeric effect. If there is any group which has got a conjugation or a lone pairs, can also show mesomeric effect and stabilizes this 3 degree carbocation. This carbocation is not an ordinary one, it is a 3 degree one. Therefore, stabilization is taking place either of one of this feature or at least mixed type of the features are there. So it stabilizes. Therefore, this steps that is Cl minus going will also takes place with a random quickly and you will get carbocation. Once the carbocation is formed, Cl minus attacks very much readily, because this is a plus, that is a minus. The type of reaction becomes into an ionic reaction now. The ionic reaction will be very fast, isn't it? So the very fast reaction, almost time of the ionic reactions will be considered as a 0. So a very fast reaction takes place and the OH minus is coming. Which side it is coming from? The not necessarily from the back side, because the 3 groups previously like this, it opened like this and both the sides place has come. Now front side Cl is not there now picture. So the Cl minus can come from the front side, can also come from the back side. With reference to the plane, 2 sides it can attack. Therefore, 2 types of answers are coming. One is from the same side, the Cl left. One is from the opposite side, Cl, opposite side, back side also, because alkyl groups opens up to make a trigonal planar. The system is a planar system is there. So a plane will have a 2 sides equally approaching. So therefore, leading to give 2 types of answers are formed. One is a same type of the answer, that is retention in the configuration. So 50% takes place retention. Why only 50% means mathematically the plane will have 2 sides equal chance. That's why 50% same configuration becomes 50% inverted configuration. That is R groups from this side to that side it goes. So 50% inversion taking place, 50% undergoes retention. Okay. So 2 products are formed, a mixture of 2 products are forming. Now let us compare the first aspect, why it is the previous one is called bimolecular, why it is unimolecular. Okay. Here in this case there are 2 steps are involved, but the second step happens to be ionic step. This is second step. In the first step the Cl minus gone, this is step 1. In the SN2 reaction only 1 step is there. Here there are clearly 2 steps are there. Step 2 happens to be very fast reaction. So there the rate of reaction will not depend on the second, only in the first step. In the step 1, what is happening is alkyl halide becoming into carbocation. What OH minus is doing? Nothing, it is waiting. So therefore, rate of reaction of the SN1 reaction is only influenced on the concentration of the alkyl halide. This is becoming into ion. So therefore, the ionization of the alkyl halide alone will be the rate determining step. So therefore, the rate is directly proportional to the alkyl halide concentration alone, not the concentration of the OH minus. That's why you call it as a unimolecular. In the previous case, what is happening in the SN2 reaction, what is happening? The Rx first becomes into the, that is from the one side OH is attacking, from one side X is going, so a transition state is formed, right? So the Cl is going and OH is coming, and transition state, the whole step becomes into only one step only. So therefore naturally the rate of reaction of SN2 is depending on the alkyl halide concentration as well as the concentration of the nucleophile also, or OH minus also. That's why it is called two species involved in the rate. So that's why it is called what? A bimolecular reaction. Here the rate depends only on the alkyl halide. Rate of the reaction is depending on only on the alkyl halide alone. So therefore this is called a unimolecular reaction. But basically 1 degree type of alkyl halides prefer to SN2 reaction. Whenever these big groups are there, this carbon happens to be a 3 degree. In such a case, these compounds are called 3 degree alkyl halides prefer to undergo SN1 reaction. It passes through an intermediate species. Previous one is passing through transition state. Here it is after step 1, what you get is an intermediate species which is a carbocation. So whenever carbocation is formed, we have a consequences like the rearrangements may takes place, stability influencing features may be dependent on that, and the carbocation is an ion. So therefore if the solvent is ionic or polar, this type of mechanism will be more favorable. And the product also in the SN1 reaction, if a pure dextro compound is taken, then what happens, 50% will become dextro, 50% will become into levo. So what finally is optical activity will be 0. That means a DL mixture, a mixture that is a DL mixture is formed, whose optical activity is 0, that is called a racemic mixture is formed. Whether you take dextro or levo, if you take a pure compound, you are going to get two products which is a mirror images, exactly mirror images. See, these two, unlike the previous case, the relation between the starting material and the product in the previous case is seems to be, isn't it? Seems to be that is a mirror image, isn't it? Here it is not like that. The two products relationship, if you see, exactly they are enantiomers because functional group is same. It's a mirror image of this one. So that's why the product will have a 50% dextro and the 50% levo. Therefore exactly opposite means a racemic mixture is formed. So the optical activity of that racemic mixture will be 0. So basically the nucleophile concentration will not be influenced in the SN1 reaction, whereas in the SN2 both alkyl halide as well as the nucleophile concentration both are involving. Therefore I call it as a bimolecular, the nucleophilic substitution. Only one molecule influencing, therefore it is called unimolecular nucleophilic substitution.